students, my name is VANILAVANYA. I am Assistant Professor from the Department of Computer Science and Engineering, St. Joseph Institute of Technology. Today, I am going to talk about the topic of resolution in artificial intelligence. So, before we getting into the what is resolution in artificial intelligence, I would like to share few words about the FOL, right? So, first I would like to say what is the FOL, which is called as a first order logic, okay. So, the first order logic, it is going to be like, for example, if you are talking like a hi, how are you, how the system will be understanding, how the machine will be understanding, that is your FOL, okay. So, you are going to convert my simple sentence or a complex sentence into a logical sentence, that is my FOL. For example, yeah, we are going to talk about the example. So, before that we need to see certain terminologies and what is the purpose of converting my fact into FOL. It has to be a machine understandable language, that is why we are moving into the FOL, right. So the fact we call it as a sentence. The sentence can be a simple sentence or it might be a complex sentence also, or it may be a paragraph also, right. So then for that we need to use certain things, something called quantifiers, okay. You might have seen this quantifiers word in mathematical also, fine. So the quantifiers, it's all the certain symbols what you are going to use for your FOL, right. So for the quantifiers, we are having two types of quantifiers. One is a universal quantifier, another one is a exponential quantifiers. So universal quantifiers, I am going to use a symbol for all. Okay, maybe along with this I am going to add certain variable like a or b or x or y. Okay, so this is going to be your universal quantifier, right. So for example, if I am saying everything is beautiful, the word every, anything I can eat, the word anything, for all, the word all. Okay, so these words like everything, anything, for all, it's all considered as your universal quantifier where it represents everything. Okay, so if we go for some specific quantifier, we go with the exponential quantifier where it is represented by using symbol that exists with certain variable of x or y or a or b, any variables you would like to give it. Okay. So this is going to be an exponential quantifier. So existing, like how we are having a keywords like a every, anything, all, the same way here we are going to have a keywords like a some, few, okay, or we can say except, right. So these kind of keywords which is going to represent some specific, that is going to be your exponential quantifier. Hope you understand what is FOL, what is conversion of FOL, and what are the quantifiers and what are the two types of quantifiers are there. In this, how you are going to implement or use these kind of symbols into my example, right. Now I am going to have certain example. So how I am going to convert my fact, these are all given as a fact. Fact is nothing but a sentence, okay. So the sentence is, we call it, technically we call it as a facts, right. So here we are having a certain example and FOL will be using some implication rules, or we call it as the inference rule. What is called as the inference rule is, inference rule means it's going to how I am going to represent my sentence. For example, inference rule, A tends to B or A implies B. This is called as an inference rule. You can use this or you can use the mathematical way like symbols A or B, A and B. We can use other symbols, other truth table symbols like A, negation of A, negation of B. You can use in any way. That's called as an inference rule. Okay. So I am going to implement these quantifiers with certain inference rules, with certain variables, how I am going to convert my fact into my FOL. Okay. First sentence, every dog barks. Okay. So here the word every, so where the every comes? Every comes with the universal quantifier. So for universal I am going to use for all x. So for all x represent every. So the X can be a dog. So for all X of dog implies barks. You can put it in this way. Okay. So instead of putting this way, you can put it R and symbol also you can use. Okay. But for this better you can use the and symbol for all, because for universal quantifiers is going to be everything. So instead of using and we can put it this way, or another way is for all X of dog or box of X. So you can put it this way also. Okay. Next, going to the next sentence. John is a student. Here we don't have any quantifiers like every, all, some, exist, nothing we have. So simply John. Who is John? John is a student. That's it. So you are going to have the class and the feature of it. That's it. Okay. Next, the third sentence is going to be, you are going to use some cats bite. So here it comes under existential quantifier. The sum comes under existential quantifier category. So I am going to use there exist of X. Okay. Okay. The third example is going to be some cats bite. So here we do have a keyword some, where you are having an existential quantifier. So I am going to use there exist symbol, because extension means I am going to use the there exists, correct? So there exist of X. Okay. And cats implies bites. Okay, bites of X, and here also is supposed to add X, because X is going to represent this dog, here X is going to represent this cat. Okay, so this sentence is going to talk about for all. Okay, for all means I am going to use the or symbol. So this one I can write it in another way also. So what I can do is cats, there exist of cats of X, and because only few cats, right, and bites of X. So you can put it in this way also. So there are two ways to do, right? So mostly we will be preferring the inference rule, that will be helpful for doing your resolution problem in the future. So let's get a practice in doing in the inference rule itself. Okay. So next it's going to have the fourth sentence. Some boys play cricket. Again we are having a sum. If it is like a for example, if it is a few also, it represents the sum only. Okay. So here I am going to have the answer of there exist of X. Okay. And that is called as a boys, and they are going to play cricket comma X. Okay. Either you can go in this way or you can go it in the truth table way. How the truth table way will come? There exist of boys and plays cricket comma X. Okay. Just instead of this I am going to use the and. That's it. Okay. Then the last sentence. John don't like chocolate. So here you don't have some, you don't have few, you don't have every, you don't have anything. So we don't have any keywords. So go with generally with the inference rule. So what I am going to do is John likes of chocolate comma X. You can put X as a John. So John of X implies likes of chocolate comma X. Here he don't like it. So put a negation. That's it. So John of X, negation of like chocolate comma X. X is representing your John. So like this, replacing your X variable with somebody's character, we call that one as an important terminology called unification. Okay, so unification means I am going to replace my J. Instead of putting dog, dog, dog everywhere, I can use X as a dog. Instead of putting cat everywhere, I can use Y as a cat. Okay, so I am just reducing my work or reducing the space or reducing the complexity of your facts. I am using the concept called the unification, and then we are going to proceed with the converting into sentences. So here first thing is FOL. Then after that we talk about the universal and extensive quantifiers with certain examples and how we are using the inference rule and how we are using the unification. These are the terminologies or the keywords which is supposed to use in our resolution, right? So next important topic is the resolution. We will be seeing with the example and the steps involved in this. So we are seeing the resolution in AI. So what is the resolution? First we need to see the definition of what is resolution, right? So the resolution, it is a theorem proving technique. For example, if I want to prove certain things or if I take certain decision if I need to take, then I go with the resolution, right? So for the resolution, it is having one more technique we call this a proof by contradiction. We can see that through our example, right? So next, this is actually invented by the John Allen Robinson in the year of 1963 itself. He is a mathematician, by the way. So he has define how to prove certain things by contradiction, how to prove certain techniques by using the theorem. That is where he stands, he did his standards. So we are following this technique in our machine learning or into our AI. So by using certain steps. Okay. The steps number 1, which is going to be conversions of facts into FOL. Second step is converting your FOL into CNF. Third step is negate the statement which needs to be proved. Okay. Final step is draw the resolution graph. There are 4 steps involved. Okay. So first step, conversion of fact into FOL. Fact, I already told you. Fact means it is a set of sentences. I am going to convert it into my FOL form. How to do the conversion into the FOL? We have seen in the previous examples with 5 examples with some quantifiers and all those stuffs, correct? So now we need to convert those kind of given facts or the given data set or the given sentence into the FOL, and then after converting into the FOL, we are converting into the CNF form, which is called the clause normal form. I will tell you how to convert to the clause normal form. Then third one is you are going to do the negation of the given statement to be proof. Here plays the major role of proof by contradiction. For example, today it is going to rain. That is your proof means it is not going to rain. That is how you are going to introduce the contradiction and you are going to prove it is going to rain. Alright. So now finally the last part is going to have a draw the resolution graph. I am going to use certain technique called unification. So the unification also I have told you in the previous example. Now let's move on to the example, right? So we have certain facts over here. The fact number 1, the humidity is high or the sky is cloudy. Number 2, if the sky is cloudy, then it will rain. Number 3, if the humidity is high, then it is hot. Number 4, it is not hot. So the final goal, it is going to be, it will rain. Okay. So the goal is going to be rain, it will rain. You are supposed to prove it is going to be rain using these 4 factors. Okay. First step, I am going to convert the fact into FOL. So for simplification, I am going to use certain variables. For example, this humidity is high, I can consider as a P. Okay. The sky is cloudy, I am going to consider as a Q. Okay. The sky is cloudy, again this is going to be your Q. Then it will rain, which is a new one, I am going to consider as a R. Okay. Then the humidity is high, which is already we know this, it is a P. Okay. It is hot, which is a new one, it is going to be PQ or S. Let me put it as yes. Okay. It is all dealt with the hot again, again is going to be hot is yes. Okay. So now how to convert this into my FOL. Okay. The step number 1, P or Q. Okay. So either this one or this one, correct? The first statement is going to be P or Q. The second statement, if it is Q, then it is going to be R, correct? So it is going to be Q implies R, which is going to be your second statement. Third statement, again if, so it is coming under the inference rule. So if it is P, then it is going to be yes. So P implies yes, your third statement. Your last statement, hot, now it's going to be yes. So if it is not hot, it's going to be negation of yes. That is going to be my last statement. And my goal, it will rain. So I have to convert my given information also into my FOL, correct? So it will rain. Where I have given the statement variable for this is R, correct? So this is going to be the R. And this is what everything is given statement. So I am going to rearrange all the statements. So step number 1 is over. Converting your fact into FOL is done. Okay. So number 1 is going to be PRQ. Number 2 is going to be Q implies R. Number 3 is going to be P implies yes. Number 4 is going to be negation of yes. Okay. And along with this, I am going to add my fifth sentence also, which is going to be R. Okay. So these are the 5 given statements and I have converted everything into my FOL. Okay. Next, I am going to go for the conversion of this FOL into CNF form. Okay. So how to convert into CNF form means, CNF form is going to explain if it is going to be A implies B, if it is like this, you need to convert like a negation of A or B. This is your rule or this is your formula. So wherever I am having like this way, I am going to convert it this way. So from here, it is moving on to the next. The first statement, nothing I am going to change, P or Q. My second statement, I am going to do the changes because this is like a implies B, correct? So Q implies R is going to be negation of Q or R. Okay. The third statement, it is also in the same way. P implies yes, correct? So this is also I am going to convert it into the CNF form, negation of P or yes. Okay. My fourth statement, I am not going to do any changes, negation of yes. My fifth statement, I am not going to do any changes, only R. Okay. Step number 2 is done. So step number 1, step number 2 is done. Now going with the step number 3. Prove by contradiction. It means I am going to convert my given statement or given goal or given conclusion into the contradiction statement. What is the given statement? It will rain, correct? So it is a R. So if I want to convert it to the contradiction, opposite, it will not rain. So negation of R, correct? So from here, my next step, I am going to repeat everything because I am not going to have certain any changes in rest of the thing. Okay. So I am going to have the same thing again in my next step. Fourth statement also same. My fifth statement, I am going to convert the negation of R. So simple. Okay. So this is going to be your after the third step, correct? So after the third step, this is going to be after the third step, and we are having a one step left, which is a final step. Okay. The final step is going to be, we are going to draw our resolution graph. We can say it's a unification also, correct? So let us draw the resolution graph. After this step, I am stepping into the resolution graph. Okay. Right. I'll continue. Okay, the resolution graph. So how I am going to do the resolution graph is, so you have to see number 1, 2, 3, 4, 5. Okay, so you have to do the unification way. Okay, unification way in the sense you have to check you can able to reduce or shrink the content. Okay, so let me take the first statement. Okay, let me compare with the second statement. If I compare, will it get shrink? Yes, it does get shrink because negation of Q and not negation of the Q will get cancelled. So the left part is going to come. So I am going to take the statement number 1. P or Q versus negation of Q or R. So this one and this one is going to get cancelled, and from here we are going to get P or R. Okay. From this solution, I'm going to check with the rest of my FOL statements. Okay. FOL conversion statement. So I can see the number 3. Okay. I'm taking number 3 where it is having a negation of P or yes. So here negation of P, this P is getting cancelled. From here I'm getting R or yes. So let me check over here. Yes, there is a fourth statement which is a negation of yes. Yes, I can reduce this also. From here I am getting R. R here I am not going to stop here also, because again I am having a negation of R. So negation of R, this symbol or this symbol, anything is good. Okay. So this is going to be cancelled, and finally I am going to get the null value. Okay. So it is going to be none. Okay. So if it is none, hence we can prove it will rain. Okay, this is how we are supposed to do. The thing is, first we are going to follow the 4th step. First step, given statement we have converted into the FOL. Second step, we have converted into the CNF form. Third step, I have introduced my contradiction in a contradiction statement. If it is yes, I am putting as a no. Okay. And finally, I am taking a resolution graph, which is a unification method, where I am going to shrink in a way where I can match with the given facts, and I can finally, if it become a none, I can prove it will rain. Okay. For example, if I am getting certain answer, I cannot do anything more than that, means it is proved that it will not rain. It is opposite. Fine. So this is your resolution problem in your AI. Let us go with another example also. Hope you understand this. So the next example is going to be another resolution problem. Okay. Alright, so previously we have used the quantifiers like P, Q, without the quantifiers like P, Q, R, like those kind of variables we have used. This example with the quantifier, that was a simple statement. It is called as an atomic statement, not very complex, but compared to the previous example, this is going to be a little bit of complex. So this is going to be atomic sentences. So what is our same 4 steps? Same 4 steps. Step number 1, converting the fact into FOL. Step number 2, converting into the CNF form. Step number 3 is going to be proof by contradiction. Step number 4, resolution graph. Same 4 steps. How this sentence or how this facts is going to be converted. So number 1, all people who are graduating are happy. So we are having the keyword all, correct? So for all x, okay, people of x implies graduating of x. All people, okay, who are graduating are happy. So we can say for all x, okay, they are going to graduate and they are going to happy. So x is called as a people. So I am replacing my, okay, what I am going to replace is graduate of x. So x is supposed to be called as a people. So for all x, graduating of x implies happy of x. So I am just shrinking instead of taking people and all those. X itself considered as a people. Okay, so this is called as a unification. So if you can take it this way also. For all x, people of x, and the graduating of x implies happy also. Yes, you can write it. Since it is that FO is little bit complicated, I am going with this sentence where this x itself representing the people. Okay, so step number 2, all happy people smile. So for all x, okay, happy of x implies smile of x. So again here also x is going to represent your people. So for all x, happy of x implies smile of x. Okay. Number 3, someone is graduating. This some is going to be the there exist. So someone is graduating. So for there exist of x, graduating of x, that's it. Okay. Then my fourth sentence, yes, of course I am going to include my fourth sentence also over here. Okay. Is someone smiling? Again someone, correct? So there exist of x, smile of x. So it is not necessary you need to add only x. In the second one you can add y. In the third one you can add some other variable like w or z. You can add anything you would like to, right? So this thing, right, this is your FOL. Step number 1 is over. What is step number 2? Step number 2 is going to be a converting into the CNF form. So first statement, yes, it is going to be like a implies B formula. So I am going to do for all x, negation of graduation of x implies, not implies, or happy of x. How this comes? CNF form. If it is A implies B, negation of A or B, correct? So negation of graduation of x or happy of x. This is your first statement now. Second statement, for all x, negation of happy of x, okay, or smile of x. Got it? Right? Next, I am going to do the third statement. I am just going to keep same as it is because there is no implies or there is no inference rule. Fourth statement, here the fourth statement is negation of x, smile of x. That is a direct conversion of fourth statement. If I am introducing my third step, it is automatically converted. So here it is going to be the complete contradiction. If the negation goes inside, what will happen? For the complete sentence, there x is going to be opposite, ulta. So it is going to be all. Okay. So for all x, negation of smile of x. Okay. So these are the final 4 statements we got it after doing all the first 3 steps. Final step, it is going to be the resolution graph, right? So the resolution graph, what I can do is, as we already discussed, we need to compare with the sentences, okay, so that how I can cancel and how I can replace my unification formula, okay, like that we are supposed to convert it, right? So here let me take my final sentence. Okay, next one more step I forgot. In case if you have a quantifiers, what you need to do is remove it. That's it. If you have a quantifiers, just remove it. So this complete portion I am going to chop it off in the next step. Okay, the complete for all x, there exists of x, that is not at all necessary when you are stepping into the resolution graph. Okay, so that portion I am going to chop it off, and then I am taking the rest of the 4 sentence, I am moving to the next one. So let me say, take anything you can take. I am starting with my conclusion step. So negation of smile of x I am taking. So I am going to match with anything with the previous. So look at your statement 2. Yes, there is a smile there also, but there is no negation. Yes, we can do the unification over here. So number 2 I am taking. Number 2 is going to be negation of happy of x or smile of x, correct? So this one is getting cancelled. So from here I am going to get negation of happy of x. Okay, now I need to compare with the rest of the sentences. Okay, so negation of happy, we need a opposite of happy. So I mean without negation, right? So you are going with the sentence number 1. It is negation of graduating of X or happy of X. Okay. So this happy is getting cancelled, right? So from here I am getting negation of graduating of X. Okay. So next I need to check with any other sentences. Yes, my third sentence is having that. So I am going to take graduation of X, my third sentence. So this graduation is getting cancelled, and finally I am going to get null value. So what I need to prove over here? My conclusion is someone is smiling? Yes. So my conclusion or what I proved over here is yes, someone is smiling. Okay, so this is all about your resolution. So we have included all the 4 steps. First step, we are converting into the FOL, and the second step, after converting into the FOL, you are converting into the CNF form. Third step, you are going to do the contradiction one, that is also done. And here extra we are adding one more rule or one more step, which is we are just going to remove the quantifier. I am going to work on the rest of the thing, right? So then it is going to the resolution graph. If you are putting in the resolution graph by doing the unification methodology, I am going to prove it is none. If it is not none, someone is not smiling, that is going to be there. So from here what we have learned is resolution is mainly for theorem proving. Okay, and if it is not theorem proving, we can put it in ML words, it is for decision making. Okay, you can use these kind of in the NLPs also in your AI, or in robotic topics also you can put like this kind of ideas, resolution ideas into that. Okay, so this FOL, it is a very traditional, this came from 1963 and till now it is having its scope where this is implemented in your real-time application like such a way like decision making, where in decision making you can use supervised learning, unsupervised learning, or even reinforcement learning also you can make use of these things. Okay, that is the purpose of studying this thing. So we listened about resolution. Before getting into resolution, we talk about the FOL. So how to convert your normal sentence into the FOL sentence. After the FOL sentence, how you can make your FOL sentence useful in terms of resolution. So resolution you are having a 4 steps. These 4 steps how you can able to convert into the unification way, and you can be able to prove it. Okay, so we have seen 2 examples today. One example is without the quantifiers, another example is with the quantifiers. Hope you understand this. Thank you for listening and watching.